Cosmology, a frontier. These are the voyages of the channel smAsho, our continuing mission to seek out new articles and new interesting science in the realm of cosmology, to boldly go where nobody has blasphemed before. Just kidding, folks. We're not going to blaspheme. So, the first article we're going to cover here is from SciTechDaily.com. Astronomers detect first signature of magnetic field on a planet outside our solar system. Yeah, there's some ionized carbon coming out of this hot Neptune. So this is only 1/20th the distance from Earth to Sun, but it's a large gas giant planet known as HATP11b, a Neptune-sized planet, 123 light years away from Earth. And there you can see it has a magnetotail. You can see ionized carbon being blasted out of its poles. And we've got different speeds here. The stellar wind is about 900,000 miles per hour. The magnetotail speed is about 100,000 miles per hour. And that's where you're getting that signal from. The disparity. A couple of Birkeland currents. Yes, some Birkeland currents are certainly associated with those jets of ionized carbon. So it's a very hot gas giant located very close to its host star. And there is the imagery showing those ionized carbon particles. So that's pretty interesting. That is yet another step forward in the realm of cosmology. A magnetic field detected on a planet outside of our solar system. Next is the astronomy picture of the day, and Comet Leonard has not reached its closest approach to the Sun yet, so we may see additional interesting outbursts from this, as it does have quite an interesting ion and dust tail, two distinct different features. You can see it showing up in different colors on that first image. And there's some more imagery of it. That's the astronomy picture of the day at apod.nasa.gov if you want to check it out yourself, taken by Danielle Gaspari. Excuse me. The video was streamed live, so I apologize for the coughing and hacking. All right. So again, yeah, we may see additional outbursts from Comet Leonard. If you want that imagery yourself, apod.nasa.gov. Let's talk about Venus. Now, Venus is an oddity when it comes to our solar system. What's up with Venus? Why does it have such a long day? Did you know that Venus's day is almost the same length as its year? I didn't memorize how long it is. That's not really important at all. Of course, Venus, as a result, has a very, very long day and a very, very long night. And it has very, very hot temperatures and a lot of carbon dioxide in the atmosphere. One of the explanations as to how Venus does what it does, because frankly, it doesn't fit in with the rest of the solar system and how the solar system allegedly formed. One of the explanations as to how Venus does what it does would be high-speed impact. So if a giant planetesimal, a bolide like the size of the moon, Earth's moon, struck Venus, this is the sort of particle and thermal model that you would get. The middle pane there is 1 hour after impact. The right pane is 11 hours after impact. And this is one of the ways to reconcile Venus's apparent lack of plate tectonics. So this is one of the explanations for how it is. Venus's mantle was affected entirely, like the entire mantle was affected by this impact. That's one of the explanations for how Venus does the weird stuff that it does, and doesn't really fit into sort of what you'd call the standard concordance model of stellar evolution, or you could say solar systemic evolution. And of course, impactors are commonly blamed. So yet another simulation here suggesting that perhaps an impactor is what caused Venus to be uninhabitable. What do you think? Let us know in the comments. Let's pick a random number between 1 and 1051, which coincides with something at the Neil Gehrels Swift-Bat X-ray Observatory. It turns out to be NGC 526. So from the new general catalog, number 52 at the Neil Gehrels Swift Observatory, is this galaxy, a Seyfert 1.5 galaxy, a type of active galactic nucleus known as NGC 526. There are the X-ray outputs from it, the transient bursts of X-rays. In the upper right, you can see the 16-year graph. In the lower left, you can see the 30-day chart, we hope. And let me just check the life of the stream here. It looks like it's streaming just fine. So let's take a look at this in some different views here. First thing we're looking at is the XMM Newton X-ray colorized imagery. And it looks like there may be a satellite galaxy associated with this. You can see this bright region right here. This may be another associated galactic nucleus. So this one may be in the process of merging with another galaxy, folks. I'm not going to say for sure because we're not really doing an in-depth study here. This is just to give folks some indication as to what they should be studying. So perhaps this is an interesting galaxy if you're interested in galactic evolution. And you can see this X-ray source out here. I believe this is another galaxy at a similar focal length. This is a rather irregularly shaped galaxy. As you can see there, that's the Chandra X-ray imagery. And let's bring up some more here real quick. Just bear with me. Here is the ultraviolet imagery. The color composition there from the Galix UV survey. And certainly it looks like there is some shared plasma envelope there. You can see some bright bits in between both of those areas. Probably some sort of an interacting galactic system there, a pair of galaxies. Perhaps something like the Large Magellanic Cloud, although I think maybe a little comparatively smaller with respect to this galaxy. So here is the DSS colored imagery, and you can see that likely interaction happening there. Something looking a little bit like a pulsar wind nebula right here as well, at least in optical wavelengths. And let's see if we can find some more optical here. I know there's some great ones by the Hubble. There's an image of the Hubble. Looks like a huge dust lane here as well. This could be another satellite galaxy. In fact, this could actually be the galactic jet. For all we know, sometimes these galactic jets are not perpendicular to the galactic plane at all. And let's see what else we can find. Again, we are streaming live here, so just bear with me a minute. How about some infrared imagery from the 2MASS? There you go. And you can see that heat signature from that likely interacting other galaxy there. Anyway, once again, that's NGC 526, entry number 52 at the Neil Gehrels Swift-Bat X-ray Observatory Transients page. There it is in infrared spectra. And that's today's cosmology segment. We hope you enjoyed it. Congratulations on realizing that the channel exists. I've been your host, Dan, a.k.a. smAsho. And thanks for leaving a comment, one audio, as I sign off from the Smash News Network, least busted name in news.